All right. Day 2, graphing quadratics in vertex form. I'm going to zip through this one a little bit quick because it's basically kind of restating what we did yesterday. And then we'll focus on actually using the skill for something new. So yesterday we looked at an equation. Let's get a pen here. It looks like this. Y is equal to a times x minus h squared plus k. And it looks crazy, but really it's just y equals x squared, essentially. But we have these three parameters, these three things that we can change that will change how the graph of y equals x squared looks. It'll always be a parabola, it'll always be a vertex. These are just going to move it around the graph and make it look like taller and skinnier or shorter and wider and maybe upside down. So how do they work? So first let's focus on the parameter k, the one at the very end. So it's outside of the squared. You have x squared all by itself and then k on the outside. And this is what we call a vertical translation. All this does is move the graph up by a value of k. Or if k is negative, it'll move it down instead. So it's going to change our y value when we're graphing, so that's going to move our vertex. So since it's only moving up and down, the vertex of our normal graph is 0, 0, so the x is still 0, but the y value of the vertex is going to be k. That's all that really changes. Our vertex is going to get graphed at the point 0, k, and then we follow the step pattern just like normal to graph it. So let's graph the quadratic relation y equals x squared minus 3. So this is going to move my graph down 3. So my vertex is going to be down here. Actually, let's do y equals x squared first, just to see the two. So y equals x squared, as a reminder, has a vertex at 0, 0, and then has a step pattern of 1, 3, 5. So we go over 1 up 1, over 1 up 3, over 1 up 5. And parabolas are symmetrical, so we get the exact same on the other side. And we can draw, ooh, that's terrible. We can draw our parabola through these points. And for our transformed, our vertex is going to be 0, k. So k is negative 3. So our vertex is 0, negative 3. So we'll graph 0, negative 3, and then we do our step pattern still. Over 1, up 1, over 1, up 3, over 1, up 1, 2, 3, 4, 5. And it's still symmetrical, so we still get the exact same on both sides. And we can draw our parabola, and it's the exact same shape as the other one. It's just starting out either higher or lower than the base graph. And that's it. All there is to it. Now, this one, we have our parameter inside the squared. So it's x minus h, and then it's being squared. So this is going to move our graph horizontally, and it's going to do it the opposite of the direction you think that it should. Because this is a minus h, then h is actually going to be the opposite of whatever the sign we read, so we have to go the other way. So that means our vertex in this one, if we're only moving horizontally, the y value is still going to be 0, but our vertex is going to have an h or an x value of h, which again is the opposite of the sign in the brackets because it's negative h. So let's graph. Let's do one. X plus 6 squared. So I'm going to do my base one again, just to kind of show what's going on. Use my step pattern to graph my 3 points on each side. Draw a nice smooth curve through all of them. And then for this one, well, our vertex is going to be 0 for the y, because we only have the horizontal translation. But it's x plus 6, so that means h is negative 6. It's the opposite of the sign. So our vertex is negative 6, 0, which is way over here. And then we find our other points with our step pattern, which is 1, 3, 5 again. So over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3, 4, 5. And then we have to mirror it on our axis of symmetry. And that's all it takes. We draw our lines through. And we should probably label whenever we graph something. So this is y equals x plus 6 squared. Whereas this one is just y equals x squared. That's all there is to it. A is a little bit more complicated. It's going to be a stretch or a compression. So to do that, we just multiply the step pattern by whatever value is in front of our x squared. So all it's doing is stretching it, compressing. It's not moving at all. So our vertex doesn't actually change at all. It's still 0, 0. So all we have to do is multiply the step pattern by this a value and graph. Let's do the base one, y equals x squared. So start at 0, 0, over 1, up 1, up 3, up 5, mirror it on the other side. And our line goes up through. You can probably draw it a little better on paper than I can on my tablet here. So that's y equals x squared. And then for this one, let's modify the step pattern. So normally our step pattern is 1, 3, 5, and so on. Well, what's my a value? My a value here is negative 1/2. A equals negative 1/2. So we're going to have to multiply our step pattern by negative 1/2. So negative 1/2 times all of these. And it's kind of like our distribution principle. It has to multiply by each piece. So our new step pattern is going to be negative 1/2 times 1 is negative 1/2. Negative 1/2 times 3 is negative 3 over 2, or negative 1 and a half, 1.5. And then negative 2.5 or negative 2.5, and so on. So we can graph. The vertex is exactly the same. I don't know why I got a heart there. Our vertex is exactly the same. And then it's negative 1/2. So I'm going to go over 1 and down 1/2. Down because it's negative, and 1/2 because that's the step size. Then we're going to go over 1 more, and we're going to go down 1.5. Down 1/2 and 1. Oh. Sorry about that. Brief phone call interruption. What are we doing? We're graphing upside down. So from our vertex, we go over and follow the step pattern. So down 1/2, over 1, down 1.5, over 1, down 1, 2.5. And whatever we do to one side, we do on the other because it's symmetrical. And then we draw our line through the dots. And that's it. Y equals negative 1/2 x squared. And this is y equals x squared. Okay, so super easy when it's just k, you move it up or down. When it's just h, you move it side to side. When it's just a, you squish it or stretch it and maybe flip it if it's negative. But in reality, we're probably going to have to combine these together. So what about when we have all of these at the same time? Well, first, we have to figure out our new vertex. And it's really easy. It's just going to be h, k. Since h moves our graph horizontally from the basic. So the normal y equals x squared has a vertex of 0, 0. This modified one is going to move it to the right h spots. So we have to change our x value of the vertex by h. The k value moves it vertically. So I have to change the vertex, the y coordinate of the vertex by k. So that's all those two do. All h and k do is change the vertex. And then we do the step pattern. We focus on a. So we do h and k first to move the vertex, and then we do a to get our step pattern. So even though there's like a lot of pieces here, it's actually just a very, very simple process every time. First, grab the vertex, which is h and k. Just make sure you change the sign on your h because it's in minus h. Then we multiply the step pattern by a to get our new step pattern, and then we use that to graph, and we're done. So let's try one. Let's draw my base parabola one more time here. Whoops. Then we go through our lines. Ooh, that was a terrible line. Perfect. So there's our y equals x squared. And then our modified. So it has a vertex of hk. So h is based on the number in the brackets, and I have to do the opposite sign. So h is -3. And then my k value is -6. So that's my vertex. -3, -6. -3 for h, -6 for k. So let's find that. -3 on the x, -6 on the y. There's my vertex. Then I'll grab my a value, which is the number in front of the squared piece. So a is equal to 2. So I'm going to be multiplying my step pattern, 1, 3, 5, 7, if you want to keep going, by 2. So my new step pattern is going to be 2, 6, 10, 14 if it fits, but I don't think it will. And that's what we use. So we'll go over 1 up 2, then over 1 up 6, and so on. So over 1 up 2. Over 1 up 1, 2, 3, 4, 5, 6. Over 1 up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, even that one doesn't really fit. Well, we'll kind of sketch it. And then whatever we do to one side, we've got to do to the other, because it's symmetrical once again. And here we go. We stretch. And that is y is equal to 2x plus 3 squared minus 6. And that's it. Everything else is just practice problems. So you have practice problems on the last two sheets today. You've got the practice problems on for yesterday. I added an extra spot on today's for step pattern. That could be useful for the ones you're doing. If you're doing the practice problems from yesterday's note, you could probably just do the step pattern in this part here, since I didn't make a spot for it. Anytime you have an a value that isn't 1, you need to calculate the step pattern. If your a value, your number in front of the bracket, is just 1, then your step pattern will just be the basic one, 1, 3, 5. That should be enough. If anything was sort of confusing today, you can watch the video as many times as you want. And I'll be back tomorrow. Take care.